In this video, we'll generate the Taylor series expansion of sine centered from 0 to 5. So we begin with the data set of sine. So array formula, sine of the x values 0 to 6. And we'll chart this. Insert chart. And we use scatter chart. Use row 1 as header and show the trend line. Polynomial to the 6th degree. For the label, use the equation. And for the legend, position at the bottom. So here we have the trend line and polynomial of the sine function. Next, we continue with the Taylor series expansion, which is the summation of a times the quantity x minus theta raised to the power n. And the value of n is from 0 to infinity. And our value of theta at the center is data validation, list of items, 0 to 5. We can start at 0, which is the Maclaurin Series, and 1, Taylor series expansion centered at 1, 2, 3, and so on. So we can start at 0. Next, we continue the Taylor series, the coefficient, the expansion coefficient. This is array formula. Sine 0.5 pi. So 0.5 times pi times n. So 0.5 times pi times n. This is a value for n. Plus theta. For now, our theta is 0. So here we have alternating values of -1, 0, and 1. So we continue with the factorial. So this is the factorial. That's the denominator. So we continue with the numerator. We continue with the denominator. Divided by factorial of n. And we show the scientific form. So scientific form. Now we can complete the Taylor series expansion. So array formula, series sum of the x minus theta. So x minus theta, that's raised to the power n, where the value of n starts from 0, incremented by 1. And the coefficient will be this range. That's the coefficient a. But there's no polynomial, so we added the chart to show the polynomial. Series, trend line, polynomial to the 6th degree, and the equation is the legend, the label. So here we have the trend line and polynomial. In red, the expansion, and in blue, which is the function sine. There's a bit of an error because this is only an approximation. We calculate the polynomial regression coefficient using LINEST. To do that, we complete the Linus matrix, starting with the power. So transpose 0 to 6. And the elements of the matrix, array formula of the x values raised to the power 0 to 6. This is the LINEST polynomial matrix to the degree 6. Now we can use LINEST. LINEST data y and data x. Again, for the expansion, this is equal to LINEST data y and data x, and enter. Now let's compare. So this is the Maclaurin series. Our center is 0. So at center 0, the coefficient x to the 0, 0. This is 0. 1.3, 1.9 times 10 to the minus 31. Coefficient of x 0.904, 0.874. Coefficient of x squared, 0.225, 0.295. Coefficient of x cubed, 0.358, that's negative 0.415. Coefficient of x to the fourth, 0.0732, 0.0954. Coefficient of x to the fifth, negative 3.13 times 10 to the minus 3, 7.15 times 10 to the minus 3. Coefficient of x to the sixth, minus 1.52 times 10 to the minus 4, plus 1.25 times 10 to the minus 4. So our center now is assigned at 1. There's the polynomials, the trend lines are the same. The expansion still approximates the sine function. At the center, theta equals 2. We still get the same results. This time it's closer. And the center at 3. Now they're exactly the same. Center at 4. They're now closer. And their data sets are almost the same. Center at 5. They're getting closer. So this completes the use of series sum Linus polynomial regression to generate the Taylor series expansion of the sine function centered at 0 up to 5. This is at 0, which is Maclaurin, centered at 1 to 5, which is the Taylor series.